For over a decade now, our digital twin technology has been helping customers across all industries to boost their productivity. Today, we offer the industry's most comprehensive, physics-based digital twin. It not only looks like the real thing, it also behaves like the real thing. It represents the exact functions and behaviors from the system in the real world. How does a product behave if we shake it or heat it up, or if we run our software on it? The twin will tell you. Let me give you an idea of what could be possible in the industrial metaverse. Imagine your factory in China is slowing down. It produces fewer parts every day. Nothing bad, but it adds up. Your team at the factory has no idea why this is happening. To fix this, you bring together a global team. So they meet and collaborate in the metaverse. They immerse themselves in the digital twin of the plant, which is the perfect mirror image of the plant. And of course, it is not a still photography. It also mirrors exactly what's happening in the real plant and in real time, down to the physical behavior of the robots. Now, the team is looking for the problem in the virtual world first, in the digital twin. To all of them, it feels as if they were at the real factory in China together. In part, that's because of the photorealistic visualization. The team decides to travel back in time in the metaverse to a point when the output had been strong. So finally, they realized that one robot on the feeder line had missed its latest software update and is out of sync, a rare miss. So time to fix it. The team updates the software in the digital twin. First, the virtual problem robot immediately speeds up. Now, the team is confident enough to update the software on the real robot at the real plant. Problem solved. This is the moment the real world starts to mirror the digital twin, a closed loop between the real and the digital worlds. So, of course, the industrial metaverse will not just help us fix things when they break. It will be a place where engineers, workers, anybody can experiment and test improvements, try out big new ideas. Also, AI bots will tour our digital twin 24/7 on their own and come up with innovative ideas to make things better. Well, the industrial metaverse will be a place where we innovate at the speed of software. It will offer enormous potential to transform our economies and industries. Now you ask yourself, who will build the metaverse? That's like asking, who built the internet? It's all of us. That's why today we are announcing a partnership with NVIDIA, a company well known for its high power computing, visualization, and AI capabilities. And I have invited Jensen Huang, CEO and founder of NVIDIA, to join us today.
If you look at the last decade of digital transformation of industries, Siemens played a giant role in laying the foundation of the journey of digitalization and started all the companies towards putting all of their design information, all of their operations information, all of their planning and manufacturing information all into a digital format. Siemens Accelerator, from CAD to PLM to ERP all the way to OT, has enabled companies to enter the world of digital. The next decade is going to be fairly exciting. It's going to be completely transformative, and it's going to do for the world's industries what it has done for the world's consumer internet companies. And the two enabling technologies that had to be invented, of course, one of them is artificial intelligence. And we've been working on that for the last decade, and we've made enormous progress. We now have the ability to write software that no humans can and perform perception, sensing, reasoning, and activation software that is really quite magical. However, something else that needs to be invented in order for us to develop the AI and also to deploy the AI. And let me explain why. In the world of developing AI for internet services, everything is software anyways. You're recommending a movie, or recommending a search, or recommending news, or recommending music. And the recommendation using AI has made it possible for us to all enjoy the internet in a personal way. However, that technology, as miraculous as it is, and it is miraculous indeed, makes a recommendation that in the final analysis, if not exactly what you prefer, does no harm. In the case of the world's industries, two things are unique. One, the recommendation that our systems are recommending engage the physical world. Means it has to make a recommendation that understands the laws of physics. And the second thing is the recommendations it makes has significant life, security, and otherwise implications. And so we have to do an incredibly good job. And so the second piece of enabling technology is this concept of a live virtual world. Otherwise, some people call the metaverse. This live virtual world has the ability to mimic the physical world in full fidelity. And it has to mimic the physical world in real time. This is the only piece of software that industries will engage from the moment they start designing their product, plant, or process, all the way through operations. And it will live on for as long as, of course, that product or that process is in operation. This is where the partnership between our two companies is so important. No company in the world has done more to integrate and to develop a comprehensive suite of tools and applications for the creation of what is called a digital twin. However, between our two companies, and now with our two companies, we can connect what Siemens makes and what NVIDIA makes, AI and Omniverse, and turn that digital twin into a live digital twin. We can now fuse information, fuse data from the point of design all the way through product life management, all the way through the automation of plants, to the optimization of the plant after deployment. That entire life cycle can now be in one world. Just as we're all in the same world of the internet, we can now be in the same world of the metaverse. And because it obeys the laws of physics, because it's real time, we can invite literally everybody who is part of the design process, from designers to planners to operators, into this world of the industrial metaverse. And so our partnership of connecting what Siemens makes and what NVIDIA makes to enable this industrial metaverse is a first of its kind. It's a gigantic technology breakthrough, frankly, and I think that 10 years from now, when we look back, we would realize today is actually a very important day, that we have taken digital transformation and gave it a giant leap forward.
What you just said, this is kind of a replay what we discussed 6 months ago in November when we met, and we figured out that when we bring our competencies, our technology, our platforms together, we can do something great. We can basically go for the full-fledged industrial metaverse, giving customers the possibility to have faster decisions, real-time decisions with higher confidence. And then we figured out that why don't we send a bunch of people from your side and our side on a mission and say, what can you do in 6 months from now in order to show what our technologies can do together as a first step? And why don't we have a look what they created?
That's terrific. Let's see.
Siemens and NVIDIA are partnering to advance industrial digital twins in the metaverse, opening a new era of automation for manufacturing. In this demonstration, we see how the expanded partnership will help manufacturers respond to customer demands, reduce downtime, and adapt to supply chain uncertainty while achieving sustainability and production targets. By connecting NVIDIA Omniverse and the Siemens Accelerator ecosystem end to end, we will expand the use of digital twin technology to bring a new level of speed and efficiency to solve design, production, and operational challenges. Siemens-Accelerator offers the industry's most comprehensive digital twin and includes best-in-class software for digital manufacturing, collaboration, design, and industrial operations. Omniverse, based on the open standard of USD, Universal Scene Description, connects a wide range of software tools and users with AI, physically accurate visualization, realistic physics, and ray-traced RTX rendering. NVIDIA Omniverse is a large-scale, full-fidelity virtual world engine and ideal for industrial metaverse. The connected platforms running on GPU-accelerated systems from edge to cloud unlock amazing superpowers, from factory planning to autonomous robots and beyond. Uniting the worlds of information technology and operational technology, the Siemens Accelerator platform uses edge-enabled devices to collect real-time IoT data connected to the digital twin. When problems occur, engineering, manufacturing, and logistics teams can immerse into the live digital twin to root cause the problem and develop a solution. New solutions can be tested and validated using the digital twin across thousands of scenarios and edge cases, eliminating the need for physical prototypes, reducing critical downtime, and increasing manufacturing agility. Siemens Accelerator and Omniverse train robot perception AI models on physically accurate synthetic data generated from the digital twin, accelerating both initial training and retraining in the event of production changes. In live digital twins, customers can train robots to perform tasks before deploying the AI models into the physical robot. Omniverse can even be used to train fleets of robots working in harmony. Industrial automation is being supercharged with AI. Inside a digital twin, customers can design environments that allow humans and robots to collaborate safely and efficiently. Together, NVIDIA Omniverse and Siemens Accelerator are bringing open collaboration to industrial automation, enabling full-fidelity, live digital twins to drive a new level of speed and agility in the era of software and AI-driven digital transformation.
Wow. That's almost like it's a real thing.
It is, and this is the start. What did it take from your perspective? What did your engineers do?
Yeah, there's several things that you saw. The amount of data that we have to load into Omniverse is extraordinarily large scale. Remember, a plant, a manufacturing plant, could be millions of square feet. There could be millions of moving parts, hundreds of millions of parts in total. And all of this data, all of this geometry data has to be able to, mechanical data has to be able to work in this virtual world. Second, we have to fuse electronics information and software information. What you saw earlier is not animation, but it's a simulation. The mechanical information, the electronics information, and the software information from largely different organizations have been brought together in this virtual world, in this industrial metaverse. And once you can bring all of this data together, fuse it together, then you can activate it. Turn it on just like we turn on a factory. We virtually integrate, we virtually assemble the factory, and now we can virtually operate the factory. The amount of data that we saw just now is extraordinary. Because of Accelerator, because of all the design suites that already captures comprehensively a digital twin and does it so well, and because Omniverse has the ability to ingest in its full fidelity all this information and turn it on, activate it in virtual integration, virtual simulation, the engineers took several months.
Right. It's not an animation, it's a simulation.
That's right.
It's not small detail, but this makes the big, big difference.
The software of the robot is operating, the software of the plant is operating to the company, to the industrial company. That virtual factory is exactly the same as the physical factory. And that's exactly the point.
Exactly. Yeah. Let me give, at this point, a great high five to our teams who did it. So everybody who was working on it, well done, excellent.
Yeah, fantastic.
And we need more. So next point is about how to bring it to the customers, how to scaling. How can we get traction on the market?
One of the things about the industrial applications is, although manufacturing is, you could imagine manufacturing theoretically being very similar, manufacturing of cars, of ships, of plants, of processes have some similarities, but they're very, very different in many ways. And that's one of the reasons why the domain expertise of Siemens is so valuable in this partnership. We bring the technology, of artificial intelligence and a virtual world, Omniverse. However, Siemens's domain-specific expertise in all of these different forms of manufacturing is invaluable to us. This partnership activates that. And nothing is more wonderful when you can find a customer who is pioneering in this way,
right,
who wants to build a future, who has the technical expertise to engage us to build this future so that we could start this journey together. And I think both of us have a mutual friend who...
Exactly, and this is a perfect leeway to our next guest here, Milan Nedeljkovic. He is CEO from BMW, and he's with us today, one of the most innovative customers in the automotive space. But let me start with the challenges. What kind of things are ahead of us, of you?
Yes, Roland. First of all, thank you very much for the invitation today. I have to say it's great to be here with you and Jensen, since we see us as a customer, but of course we are more. We are partners on that one. We are working together, and I think especially working on the digital world and the future is something exciting and can set the pace working in a collaboration and doing it together. And since you're mentioning the challenges and changes, somehow everything is in a change and all at one time. COVID lockdowns, we had semiconductor shortages. We had to react very flexible and spontaneous to changes and always to provide the right product to the customer in that time. I think with BMW, we have a highly flexible production system, but looking into the future, it will become more and more important to link the supply chains, the suppliers, to get transparency in the whole process chain, and that's a digital challenge we are facing there. At the same time, we have a transformation of the industry in different dimensions. One is for sure the electromobility. It's ramping up. Customers are buying the cars. We are providing the right cars for the customers. By the end of next year, BMW will offer 13 fully electrified cars. They need to be produced. So we are changing our equipment. We are changing our production environment, processes, and equipment, and all that needs a good planning. Sustainability is for us a significant transformation field. Premium means sustainability. And that's why we are today already benchmark in the automotive industry, but we have set ourselves a target in this decade, till 2030, to reduce 80% CO2 emission by car on top of that. And all that shows there is much to do, and an enabler for all that is, again, a digital world.
Milan, I've had the benefit, if I could just say something about BMW's Miracle. I've had the benefit of visiting your factory in a digital metaverse, in Omniverse. And this is really quite an extraordinary thing. You build 2.5 million cars a year, 99% of it is customized. You're manufacturing this in 31 different factories, and somehow you roll out a car, I think it's once every, is it minute or an hour?
Every minute.
Roll out a fully customized car every single minute. And now you have to replan your factories to be able to support ICE as well as electric. Really quite a miracle.
Yeah, thank you very much for this compliment. Looking onto the complexity, that's the core element we have somehow to manage and find a way how to plan it in the right way, and especially how to steer it in the right way. And since we are working on this digital twin approach together, we see the chance to get a grip onto it, and that's a great perspective, I think, which is worth looking in detail into it and setting ourselves a significant target.
And these challenges you have to manage all at the same time. This is what I understood. So it's a real transformation, what we see in the automotive industry. And BMW's answer to that is iFactory. Is that right?
The BMW iFactory is our master plan for all these transformations. So it's our vision of the production of the future. And we say the iFactory is lean, green, and digital, and I think it explains it by itself. So with lean, we want to have efficient processes, lean processes, but also flexible processes. This is the core, the heart of our production system. We want to be green. We are developing individual footprints for each single production site worldwide. And we have to adopt new ways of energy management in our sites. And of course, digital. That's the core enabler. We must transform from our legacy systems into a future where data is seamlessly transmitted, where transparency is given, where we are talking of flow systems which link into our machinery with edge computing and which goes into applications. And all that must be one unit as a twin of the production and the steering complex of the production.
AI-Factory. The first time I heard that from Milan, I realized that they realize that the factory is as much of a product as the product that the factory is trying to make. Yeah. And yet all engineers would design digitally with CAD, we would simulate, we would stress test, we would optimize, we would be connected to our product, we would continue to refine it with OTA over time. But yet, very few companies would treat their plants that way, to design it digitally, to simulate it, to fuse all the data, to simulate it cohesively, to stress test it, and iterate it and optimize it over time. So the fact that you name the factory a product says a lot about your attitude about the factory.
Your manufacturing side, the idea is once you have this digital twin, that you go for optimization in a continuous way. I mean, you will build a brilliant one, but there will be always improvement potentials. You have changes in your cars, you have changes in your products, and then you improve it. That's part of the exercise why you digitalize too, right?
Yes. For us, it's important to get transparency and also to use the capabilities for digitalization. And we have different pillars we are looking at. One is connectivity. We must get seamless connectivity, easy connectivity, flexible to adopt 5G networks in our systems to easily have small applications being used and then again changed over time. We need artificial intelligence being used in our equipment. For me, artificial intelligence is the next big thing for automation in a production field. To use it for camera systems in quality areas, to use it for the logistics transports, to use it in maintenance and machine steering. So artificial intelligence is boosting right now and gives us huge opportunities. And last but not least, virtualization and the digital twin. To bring everything as digital twin into a virtual world opens a complete new dimension. We are getting the opportunity to set up our systems, plan the systems, link them into the real planning fields, connect people, and at the end of the time, even steer the whole plant with it. So it's a huge field we are tasking.
And then when I just quoted a little bit of our discussion which we had, then I said, let's start with the line. And you said, no. This digital twin has to be comprehensive. It has to be a full digital twin from the shop floor to the roof, from your robots to the cars to the products. It has to be complete, right?
It has to be complete. Jensen, we did some work the last year to bring our facilities into a digital twin, to generate more or less the basis for a digital twin. But the important thing is to link it into existing systems, to really have the reality and the twin always fit to each other, and then have the capability with artificial intelligence inside the digital twin even to steer the factory. That's a huge approach.
And then when we talk always about having real-time decisions with confidence. Mm-hmm. That means, at the end of the day, if you simulate something on a digital twin and you figure out you want to change something in the real world, then you should. That means you really change the real world, and you better get it right first time. This is the big difference between what you described before, the internet or the metaverse and the industrial metaverse. We are talking about impact in the real world.
That's right. If you look at almost every engineering project today of any significant complexity, we simulate the product before we go to production. And because almost all products today are software defined, there's a great deal of software that sits on top of it. We essentially, all companies that build products have a digital twin. BMW has a digital twin of the car. And they would simulate new software releases on the car before you release it OTA into the fleet. NASA does that for the rovers. Companies do that for phones. We do that for our chips and computers. Yet, for most plants and most factories, it's nearly impossible to do that today. And the reason for that is because a plant building a whole bunch of products is way more complicated. There are millions and millions of parts. Many of them are moving. The amount of software that's inside a plant is incredible. And so we need to create a very large-scale simulation platform, which is what Omniverse is about. It has to be physically based, just like Omniverse, and it has to fuse data of all modalities, whether it's mechanical, electronic, or software. We need to be able to put that into Omniverse and simulate this plant. And so in the future, Milan, you will develop new software, you will change the layout of your plants, maybe you change the procedure of the workers in the plant, and you would simulate that in your virtual digital twin, and you will prove that it is optimal and safe before you OTA it into your plant.
That sounds great, but that seems to be really expensive. Why would I invest in this one? I mean, did you think about it, about the investment which you have to do in order to make that really digital twin?
The core element is to get started. I mean, we got started and we are going from one step to the next. It's an adventure since we are approaching new fields. The digital twin itself, I mean, many fields, as you say, have digital twins already. The digital twin itself is not the challenge. The challenge is to link into this digital twin the existing systems, one by one, and to have any change in the digital twin being reverted in the original planning tools. To get the digital twin as a full digital twin means to use it with sensors into the manufacturing and use it as a steering brain for the reality. This is something from today's point of view. It's a vision. It's not here yet, but work on it step by step. And at the end of the day, the benefits are huge. So I think it's worth doing it.
You told me a long time ago that you would like to improve the operational efficiency of manufacturing by 30%. Now, for a company the enormous scale of BMW, 30% of manufacturing could drive enormous efficiencies and cost savings. That's one of the reasons why it makes so much sense and so compelling for you to make the investment. The world's industries represents hundreds of trillions of dollars over time. And to be able to find several percent of efficiencies represents trillions of dollars a year. That's one of the reasons why people want to invest, and now we have the technology capable for them to do so. The second thing is the source of truth. The source of the data has to have high integrity and has to be full fidelity, which is exactly the reason why we're connecting today. This partnership today is about exactly the problem statement you just described, which is to connect directly from the tool that the engineers are using, directly from the data that they're actually using, connecting it directly into Omniverse and creating the digital twin, the live digital twin. And so that's the purpose of our partnership, and we're going to go make it happen.
And Jensen, you're completely right. 30% is absolutely realistic. If you think of a steering, of safeguarding the processes, of being able to visualize them and change them before you have them in hardware and before you have any mistakes. So the potential is huge. And for me, the vision would be with our new plant in Debrecen, fully electrified plant, 100% CO2 free. It's the vision of the iFactory. So to get the full digital twin in place with Debrecen, that would be the right approach.
And I do believe that the leverage on levers, is it productivity increase, is it shortening cycle time, is so big that it justifies investment and it justifies really taking the effort. Which brings me to your Hungarian plant, which, and we talk, here comes the fun part. You talk about a vision. Very often people think visions are out maybe 10 or 15 years. So I think the challenge is to make that happen by 2025?
2025,
so
yes.
Remember, we are 2022 right now. So that's. I mean, you said before, maybe 3 years in my business. That's quite long.
That's forever. 2025. It's 2025 for the virtual version or the physical version?
The physical version.
Oh, really? Okay, so what that suggests you and I
has
have to have the virtual version in about 6 months. And so that Milan could integrate it, operate it, optimize it before he breaks ground.
So we
use it for steering.
So we should give it a try. That the digital version is faster than the real one.
There's no question the digital version will be faster than the real one. Let's make it happen.
Let's try it. Let's give it a shot.
Let's do it.